Alright guys, today we're going to take a look at solving quadratic functions and equations by using the quadratic formula. So the first example that would be in the textbook would be 3x squared minus 4x minus 9 is equal to 0. And we're going to label what A equals, what B equals, and what C equals. I know it's been a minute since some of you have seen the quadratic formula, but I'm going to write that quadratic formula down here. The quadratic formula is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all of that over 2a. That's our quadratic formula, and that's the formula that I'm going to be referring back to. So now that we know what a, b, and c are, we can just plug it straight into this formula. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2a. So what I always try to do is I always try to simplify what is under my radical first. So when I put that in my calculator, I've got negative 4 squared minus 4 times 3 times negative 9. And I get 124. So I've got x is equal to negative and negative make a positive plus the square root of 124 over 6. Automatically try to see if the square root of 124 is a perfect square, and it is not in this case. So what I have to do is I have to simplify that square root. So I'm going to come up here just because I don't have enough room, and I'm going to take the square root of 124. I'm going to just go to y equals 124 divided by x, and I'm going to look, remember, over here for your largest perfect square. And there's my largest perfect square, 4. 4 times 31 is 124. So I've got the square root of 4 times the square root of 31. Square root of 4 simplifies to 2. So now what I do is I come over here and I rewrite this as x equals 4 plus or minus 2 times the square root of 31 over 6. This is where it's important to pay attention to these numbers, the one in front of the radical symbol and these other two numbers. Do they have anything in common? Can anything be simplified? Well, 2, 4, and 6 all have a 2 in common, so I'm going to factor out a 2 to leave me with 2 plus or minus the square root of 31 over 3. So that was our example that was out of the textbook. So let's take a look at the example in your text or in your notes. Alright, so what I've got in my notes is, first of all, I'm going to draw a line, that way I don't work too far over. We'll figure out what A equals, what B equals, and what C equals. So x equals the opposite of b plus or minus the square root b squared minus 4 times a times c, all over 2a. So x equals, remember I go ahead and simplify what's underneath my radical symbol. 6 squared minus 4 times 2 times 3, get 12. Negative 6, oops, not 16. Negative 6 plus or minus the square root of 12 over 4. Square root of 12 can be simplified to the square root of 4 and the square root of 3. The square root of 4 is 2. So that's going to be negative 6 plus or minus. That's fine. Negative 6 plus or minus 2 times the square root of 3 over 4. That's not my answer because 2, negative 6, and 4 all have something in common. We can factor out a 2. So my final answer would be x equals negative 3 plus or minus the square root of 3 over 4. Not 4. 4 divided by 2 should give me 2. Sorry about that, guys. Alright, and then my second one over here. A equals 3, B equals negative 2, C equals 7. So x equals the opposite of 2, or of b, plus or minus the square root of b squared minus 4 times a times c. All over 2a. Negative 2 squared minus 4 times 3 times 7 is negative 80. So 2 plus or minus the square root of negative 80 over 6. Square root of negative 80. I'm going to factor out a negative 1 and a negative 80. Negative 1 is I. But let's see if 80 can be factored in further. Remember, we look over here for our largest perfect square. We go back up to 1. And I got my largest perfect square here at 16 and 5. So the square root of 16 times the square root of 5, which is equal to 4. So we got I. So all of this equals 4I times the square root of 5. 2 plus or minus 4i times the square root of 5 over 6. We're not worried about what's underneath the radical when I look to see if these can be simplified. 2, 4, and 6 all do have something in common, and that's a 2. So my answer is 1 plus or minus 2i times the square root of 5 over 3. Alright, number 2 says solve the equation, use the quadratic formula, and then a separate equation. So we're going to let A equal 6, B equal 1, and C equal negative 15. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all over 2a. So x equals negative 1 plus or minus the square root of 1 squared minus 4 times 6 times negative 15. That gives me a positive 361 over 12. Square root of 361 is 19. So negative 1 plus or minus 19, not square root, is plus or minus 19 over 12. So we've got x equals negative 1 plus 19 over 12. which is 3 over 2. And we've got x equals negative 1 minus 19 over 12. Which is negative 5 over 3. Right, they told me they also wanted me to solve it using a different method. So I'm going to solve it using factoring if I can. So that's 6x squared plus x minus 15 equals 0. We use bottoms up method, 6 times negative 15 to get an x squared plus x minus 90 is equal to 0, which gives me x plus 10 times x minus 9 is equal to 0. We can't forget to go back and divide by our a value. X plus 5 over 3 times x minus 3 over 2 is equal to 0. Bottom up, so my two factors are 2x plus 5 times 2x minus 3 equals 0. Well, that's not our answer, because to figure out what our answer is, we have to set each factor equal to 0. And I wrote the wrong thing. That should have been a 3. So 3x is equal to negative 5, where x is equal to negative 5 over 3. And 2x minus 3 is equal to 0. 2x equals 3, and x equals 3 over 2. Alright, example 3 talks about how to identify the real, or how many number of solutions. So I'm going to give you this list that I want you to write out. If discriminant is, and you may be wondering, what in the world is the discriminant? Discriminant is the inside of the radical, so b squared minus 4ac of that quadratic formula. So if our discriminant is positive, that means we have 2 real roots. If our discriminant is negative, that means we have 2 non-real roots. So that means that there's going to be an imaginary part to it. And if our discriminant is 0, that means we only have one real root, and that real root is going to be, it's just going to be one real root. So let's figure out how many solutions we have for each of these equations. So a equals 16, b equals 8, and c equals 1. So 8 squared minus 4 times a times c. Plug it in my calculator. 8 squared minus 4 times a times c. And that gives me 0. Since our answer is 0, that means we have one real root. For b, a equals 2, b equals negative 5, and c equals 6. Negative 5 squared minus 4 times 2 times 6. We get a negative 23. So since that is negative, that means that we have 2 non-real solutions. 2 non-real roots. Alright, moving on to the next page. We are going to actually skip through this. And then they want us to be able to use the discriminant to find a particular equation. Well, let's see. I'm going to work out the example in the book, which was 2x squared plus bx plus 18 is equal to 0. The directions in the book say determine the values of b that ensure 5x or 2x squared plus bx plus 18 is equal to 0 they only want us to have one real solution or one real root. So this one's going to be a bit different than this one, but it's going to be good for you to see both. So looking at this, I know a equals 2 and c equals 18. So we're going to find our discriminant. We know we got b squared. We don't know what b squared is, or b is yet, times 4 times a times c. And we know that that should equal to 0. Well, if I've got b squared, multiply all these numbers together. 4 times 2 times 18. I get 100 and, oh, that should be a minus. 144 is equal to 0. Solve for b. So b is equal to plus or minus 12. Well, what does that mean? If we want real solutions, two real solutions, that means that b has to be greater than 12 or b has to be less than negative 12. If we want non-real solutions, that means that b has to be between negative 12 and positive 12. Or if we want one solution, that means that b has to equal 12 or b has to equal negative 12. And what this asks for is what could my equations be, or what would my values for b be for me to have one solution. They would either have to be a positive 12. I'm sorry you didn't see all that. They either have to be a positive 12 or a negative 12. So we're going to do the same thing, but this time we need to have two non-real solutions. So we let a equal 5, c equal 5. B squared minus 4 times a times c is equal to 0. B squared minus 100 equals 0. So b squared is equal to 100. Take the square root. B is equal to plus or minus 10. So let's think about this. If we want two real solutions, b has to be greater than 10, or b has to be less than negative 10. If we want non-real solutions, b has to be between negative 10 and positive 10. If I want one solution, b has to equal to negative 10, or b has to equal to positive 10. What this is asking for is two non-real solutions, so what it needs to happen is I need b to be between negative 10 and positive 10.